This is the screencast for section 2.8, example 5. We're going to create a sign chart for rational functions. So the difference between rational functions and polynomial functions is a big old denominator. A rational function is a polynomial divided by a polynomial. So if I'm going to look at all the values that I'm going to use on my number line, not only do I need zeros this time, I also need anything that's going to make the rational function undefined. We call those critical values. Critical values are x values that make the function equal to 0 or undefined. Those values, a 0 or a vertical asymptote, would give the the rational function an opportunity to change from positive to negative or negative to positive. So when looking at r of x, my critical values are negative 1/2, because that would make the numerator 0. Those would make the denominator 0. So I'm going to put those on my number line. Negative 3, negative 1/2, and positive 1. Now the shape of the function I'm going to test on my number line is 1 quantity in the numerator and 2 quantities in the denominator. So I'm going to create that shape in every piece of my number line. Also, here is where it is extremely important to label the numbers you're putting on the number line as to whether they are a 0 of the function or a undefined, an x value that makes the function undefined. So 3 is going to make the denominator 0, so that's going to make the function undefined. Negative 1/2 makes the function 0, so that is a 0. Positive 1 makes the function undefined. And you'll see how those come into play, because A is asking for x values that make the function 0, B undefined, C positive, and D negative. So we need to clarify the difference between 0 and undefined. Alright, so I'm going to pick any number to the... negative 3. There we go. I'm going to pick any number to the left of negative 3, so negative 5,000. The numerator will be negative. The negative 5,000 plus 3 will still be negative. Negative 5,000 minus 1 will still be negative. Two negatives make a positive, so a negative divided by that positive would be negative. In between negative 3 and negative 1/2, the easiest number for me is negative 1. 2 times negative 1 plus 1 is negative. Negative 1 plus 3 is positive. Negative 1 minus 1 is negative. So I will have a result of a negative divided by a negative would be a positive. Then easiest number between negative and positive is 0. 2 times 0 plus 1 would be positive. 0 plus 3 is positive. 0 minus 1 is negative. That would result in a negative output. Anything bigger than 1, I'm going to get a positive in the numerator, positive in the bottom left, positive in the right, and the overall value is positive. Okay, before we start labeling what the answer to A, B, C, and D is, I want you to look at this graph to show you exactly what we just did here. The values to the left of negative 3, the x values when I plug them in, will produce a y value less than 0. There it is. Between negative 3 and negative 1/2 will produce positive y values. Those are right there. See how at this undefined, this vertical asymptote of negative 3, the values switched from negative to positive? Vertical asymptotes give a rational function an opportunity to do that. Now between negative 1/2 and positive 1, those x values will produce positive y values. Again, we hit another asymptote, which gives the function an opportunity to switch to positive values, which it does. We have positive y values produced by any x value greater than 1. So our our sign chart is a good way of organizing which x values make the y values positive, negative, 0, and undefined. So to answer our questions, A, the x values that make the function 0 are simply x equals negative 1/2. That is the only 0 on this entire function. B, the x values that make the function undefined are both -3 and +1. C, the values that make the function, the rational function, positive, the x values are, let's see, between -3 and -1/2, not including, and then again from 1 to infinity. Now, -3 does not make the function positive. It makes it undefined. -1/2 doesn't make it positive. It's 0. And then 1 makes the function undefined, not positive. So then, last but not least, D. Where is the function negative? That will happen from -infinity to -3. And then again from between -1/2 and 1. For the now try problem number 25, I'm again going to identify the critical, not circular, but critical values. Any x value that makes the function, the rational function, 0 or undefined. So those would be +1 will make the function 0, -3/2, and +4. So those are the values I'm going to put on my number line, as well as label them according to what they make the function. So -3/2 will make the function undefined, +1 will make the function 0, and then +4 will also make the function undefined. So I'm going to test a really negative number to the left of -3/2. I get all negatives, so overall I have a negative answer. A negative divided by a positive would be a negative. I'm going to test out 0 between -3/2 and 1, resulting in positive y values. The x values between 1 and 4, I'm going to pick a random one, I don't know, 2 or 3, it doesn't matter, would result in overall negative y values. And then last but not least, anything bigger than 4, it's going to be positives across the board, so overall the results will be positive. So the answer to part A, where is the function 0? That's x equals 1. Where is the function undefined? That's going to be x equals -3/2 and +4. They both make the denominator 0. Where is the rational function positive? That's going to happen between, not including, -3/2 and 1. 1 makes the function 0, which is not positive. And then again after 4 to infinity. And then part D, where is the function negative? That is going to be from any x value between -infinity to -3/2 will produce a y value that's negative. And again, between but not including 1 and 4, 1 makes the function 0, which is not negative.